So the first one, it says, when the starting pistol fires, the racer starts from 0 meters per second and accelerates until they're running at a constant speed of 8 meters per second in a straight line. What's the change in velocity? So this one's just asking for change in velocity. So we need to identify givens. We have right here 0 meters per second. That's the initial velocity. And they accelerate until they're running at a constant speed of 8 meters per second. That's going to be the final velocity. So even though this is just a subtraction, I'm still going to go through all the steps of writing out the givens, the equation, and then plugging it in. And they're asking for change in velocity. So initial velocity is 0 meters per second. Final velocity is 8 meters per second. And they want to know change in velocity. Remember the delta, that triangle, Greek letter delta means change in. So equation, change in velocity is the final minus the initial. Then plug in those givens, so then it's going to be 8 meters per second minus 0 meters per second. So then the math on that one is easy. 8 minus 0, change in velocity is 8 meters per second. The change in velocity is positive. Does that make sense? Should it be positive? Yes, because they were speeding up. They were speeding up, so change in velocity is positive. The second one is also a change in velocity, so let's skip down to an acceleration one. Let's do number 5. That's a good acceleration one. Okay, a crow is sitting at the side of the road. It takes off when a car approaches. After 29 seconds, the crow is flying 7 meters per second. What is the crow's acceleration during that time? So I'm going to read the problem, look for givens. After 29 seconds, that's a time. The crow is flying 7 meters per second. 7 meters per second, is that the final velocity or initial? Is this final or initial? That's the final velocity. So what's the initial velocity?
0.
How do you know that? Yeah, it's sitting there, so that means this is going to be the initial velocity. And they're asking for acceleration. Okay, so listing out the givens. Initial velocity is 0 meters per second. Final velocity is 7 meters per second. Time is 29 seconds. And acceleration is what we're solving for. So then writing out the equation that I need to use, set up to solve for what I'm trying to solve for. I'm trying to solve for acceleration. So acceleration is final velocity minus initial velocity over time. So then I'm going to plug in my givens into that equation. So 7 meters per second minus 0 meters per second over 29 seconds. Now I know the 0 in here makes it easier, but make sure you're plugging it in and putting parentheses around everything on the top. You need to do that first. If you just plug it in all in one row, then it's going to do order of operations. It's going to do 0 divided by 29 first, and then 7 minus that, and that's not right. Your calculator is only as smart as you tell it to be, so you need to make sure that you're plugging things in correctly so that your calculator does order of operations right. Otherwise, your calculator is going to do exactly what you tell it to. If you don't tell it to do the right thing, then it's not going to get you the right answer. Okay, so plug it in. What do you got? Who's got an answer? Naya? Good, that's what I got too. 0.24. What are the units? Good. 0.24 meters per second, meaning it's changing its speed 0.24 meters per second every second. Let's do one more acceleration one together, and then I'm going to let you on your own for the rest of them. One that doesn't involve a 0. We can do 7. Right at the bottom. Okay, calculate the acceleration of a skateboarder who accelerates down a ramp in 3 seconds, increasing their speed from 1 meter per second to 4 meters per second. So 3 seconds, that's a time. Increasing their speed from 1 meter per second to 4 meters per second. So 1 meter per second, that's the initial velocity. To 4 meters per second, that's the final velocity. And they're asking us to solve for acceleration. So then write down your givens. Time is 3 seconds. Initial velocity is 1 meter per second. Final velocity is 4 meters per second. Acceleration is what we're solving for. Set up the equation. Acceleration is equal to final velocity minus initial velocity all over time. Then plug those givens into that equation. So it's going to be 4 meters per second minus 1 meter per second all over 3 seconds. Again, when you plug it in, make sure you put parentheses around everything on the top. You need to do the 4 minus 1 first, then divide it by 3. And then, did you plug it in? What'd you get? Did everybody else plug it in too besides Naya? Yes? No? Yes? Okay, good. Alright, Naya, what'd you get? What? I'm sorry, say that louder.
1 meter per second.
Good. Meaning that skateboarder is accelerating down the ramp, so they are having a positive acceleration, they're getting faster, and they're increasing their speed 1 meter per second every second. So every second they're getting 1 meter per second faster. Okay, I want you to work on the rest